Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at now electrostatic, right? So yes, so I have a charged sphere M is suspended from a ceiling by a light extensible string, insulated string. Okay, another charged sphere N of mass of this one of mass that one carrying a charge of that one. Okay, let me erase this. Carrying a charge of that one hangs stationary, very, very key, stationary vertically below sphere M. The centers of the sphere are 0.3 meters apart, the centers of their sphere, as shown in the diagram. So we have M and N like that, right? So they are at a distance of that one apart, right? But now I want us, before we look at the questions, I want us to be in a position of saying, we know that this object cannot hang just vertically upwards like that. Which one is hanging vertically upwards, actually? N, okay. So they are telling us N is hanging vertical downwards, upwards. It is in A like this, okay? We know that cannot happen unless now there are forces that are keeping it. Remember, N will experience a net for Fg. N will experience Fg. Okay, so now when it experiences Fg, what causes it to be stationary? It should be the electrostatic force they exert on each other. So it means now this will be the force that M exerts on N. Okay, M exerts a force on N that causes N to move upwards. Okay, like that. Then this also moves downwards like that. So they have electrostatic force like that. Okay. So this is the only way in which now N can be at stationary hanging like that. Okay. Yes. So now state Coulomb's law in words. So the magnitude of the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between them. Between their centers, it is where you use it in gravitational law. Here we say between them. State whether the charge of M is positive or negative. The charge of M, let's look at N first. N, it is positive again. N, it is positive, right? So we see, okay, for us to have a balanced force, it means now the electrostatic force that they exert on each other should pull N like that. So if this is positive, this should be negative. Why? So that what? So that M can pull N upwards, okay? But gravity also pulls N downwards, so like that. So it means now, so that we can have what? Balanced forces. You can say this is electrostatic force, okay? But it is electrostatic force uh, from N due to N, okay? Sorry, experienced by N due to M, like that, okay? They say draw a labeled free body diagram for sphere N. For sphere N, here it is. You can just replace this with a dot, okay? Remember how to draw a free body diagram? You just replace this with a dot. There it is, my free body diagram. Cool. 19.4, calculate the magnitude of the charge on sphere M. Magnitude of the charge. What is the charge, Han? Magnitude of Q on sphere M. Again, on sphere M, how can you do that? Remember I said Fe should equal what? Fg in this case. Okay, let's talk about N. When we talk about N, we know that Fg should be equal to what? To Fe. We know the force of M, the force that M exerts on N should be equal to what? To Fg. This is what is referred to here, right? This is what we see there of, okay? Therefore, what is F? The force that M exerts on N, it is what? Electrostatic force. So it's gonna be K QM QN divided by their distance squared. Okay, and then what is Fg? Fg, I know it is mg. Okay, but now the mass that I'm gonna talk, I'll be talking about, it is the mass of what? The mass of N, because I'm doing this for N. Okay, You can say F net is equal to MA. You can start by saying F net, it is equal to MA, then Fmn minus Fg, it is equal to 0, because now it is that stationary. Okay? When I choose upwards as positive, it is that stationary, then you take that to the other side so that you do not say I'm doing magic. Okay? So therefore, I can be in the position of substituting and saying 9 times 10 to the power of 9. What is charge of M? Charge of M, I don't know. That is what I'm looking for. Charge of M is what I'm looking for. Charge of N, they told me it is something like positive 8.6 times 10 to the power of negative 6. Are you correct? Yes, 8.6 times 10 to the power of negative 8 instead of 6 rather, okay? Negative 8. Divide by the distance squared. Is it in meters? I should confirm if it is in meters now. Yes, 0.3 meters. So 0.3 meters squared. It is equal to mass of the what? Mass of N here. Mass of N, it is how much? Mass of N, it was given to me as how much? 2.04. Okay? 2.04 times 10 to the power of negative 3. Therefore, G, it is 9.8, like that. Then you should be in a position of knowing how to do your mathematics. What I'd advise you to do, take this one and multiply it to the other side, then divide by these two. Divide by these two. So on your calculator, I'm going to say into 2.04 multiplied by negative 3 multiplied by 9.8 multiplied by 0.3 squared, then all that is divided by how much? By 9 times 10 to the power of 9 divided by 8.6, okay? 8.6 times 10 to the power of negative 8. Then I get a very, very unique charge of, let's think if I'm correct, of 2.32 times 10 to the power of negative 6 coulomb. Let me see if I did not do any mistake. Let me repeat the process. 2.04 times 10 to the power of negative 3 multiplied by 9.8 multiplied by 0.3 squared. Then we all divided that by how much? By 9 times 10 to the power of 9 multiplied by 8.6 times 10 to the power of negative 8. I get 2.32 times 10 to the power of negative 6 again. So there is the charge. First mark is you realizing that it is equal to 0 like that, okay? Then substituting here, okay, the formula here, substituting on this side, substituting on that side, then the final mark. Okay, yes. Very, very, very interesting question. I really liked this question thereof. Now they tell us that how much. So they say to us, how much does the electrostatic force that M exerts on N compare to that exerted by sphere N on M with respect to magnitude? Okay, let's talk. How does the electrostatic force that M exerts on N? Let's come here and say M exerts a force on N that goes up. Can we see that? Let's also draw a flow diagram for M. Okay? For M. M will be that tension like that, okay? But it will experience a downwards force, the force that N exerts on M. Can you see? The force that N exerts on M, it is downwards. So now the question is, how does the electrostatic force that sphere M exerts on N, sphere M exerts on N, this one, compared to that exerted by sphere N on M? Magnitude is the same. Magnitude is the same, or you can say equal, but direction, it is opposite. Direction, it is opposite. We need to compare, okay? Magnitude is the same, direction, it is opposite. Can you see? This one, it is up, this one, it is down, but the force is there, is the same. I want to believe you're following. Okay, let's erase that and leave out the space for a new calculation. Okay. They tell us point X is 0.1 meters vertically downwards. between the center of N, below the center of sphere N, as shown in the diagram 2. Calculate the net electric field at point X. So remember, X, it is a point charge. Always X, it is a positive point charge, unless they told you it is negative point charge. So we want to find the net electric field experienced by X, okay? So now, remember, this is Zhuang, N, it is positive, this is negative, okay? So now, X will experience an electric field that repels it due to N, okay? X will experience a electric field due to N that causes it to go down. Why? Because they repel, okay? They repel like that. Can you see that? Mm-hmm. But what is happening between M and N? What is happening? There is an attraction. So M is pulled that way, then X is pulled that way. So this is the electric field that X experiences due to M. So now, if we were to calculate now the net electric field, it means now we need to calculate the electric field due to M, also the electric field due to N, and do the what? Do the net. Okay, I'm gonna say okay. I'm gonna say okay. Now I like to do it in one step. I'm gonna say okay. E net, it is equal to electric field due to M plus electric field due to N. And I will choose going upwards as positive. Okay. Therefore, if that's the case, I'm going to say E net, it is equal to EM. I'm going to say it is KQM divided by R squared. Okay. Therefore, plus or minus EN, it is moving downwards. Can you see? EN, it is moving downwards. So it means it should be minus KQN divided by R squared. Actually, I mean EN, it is moving downwards. Why? Because X will experience a repulsion force. X will experience a repulsion force from N. Why? Because they are both positive. Therefore, the electric field that X experiences due to X, the electric field that X experiences due to N is going to be downwards because they are repelling. But now the electric field that X experiences due to M, it is going up because X will want to move up to that negative. Okay, yes. Therefore, we say E net, it is equal to 9 times 10 to the power of 9. Then charge of M we calculated as 2.32 times 10 to the power of negative 6 divided by the distance between X and M. The distance between X and M, can you see? Between X and M, it is how much? 0.4. Very, very important. Between X and M, the distance, it is 0.4. Very, very, very key. Very, very, very key to understand thereof. Minus 9 times 10 to the power of 9. Charge of N, I remember very well, it was positive 8.6 times 10 to the power of negative 8. Then the distance between N and X. The distance between N and X, it is how much? It is 0.1. Very, very, very key also. Very, very, very key also. Very, very, okay, let me do this. Very, very arsa. Let me leave it. Very, very key that you know the distance. You can check the distance very well. I have 0.1. Therefore, the inlet that I get there, it is, okay. When I check the direction here, this one will experience a greater repulsion force. It means now the electric field due to N will be greater as compared to M. Why? Due to the distance. If the distance is low, the electric field will be high. Why? Because E is equal to KQ divided by R squared. If the distance is low, the electric field is high. So it means now EM will experience the electric field due to N on X will be greater than electric field due to M to X. Okay, so now if you draw it in terms of scale, it's gonna be like that. Okay, therefore it means I'm expecting an answer that is negative. Okay, that is gonna move downwards. So it means the net electric field that X experiences moves it downwards. So let's see if the answer thereof that I expect is correct now. 9 times 10 to the power of 9 multiplied by 2.32 times 10 to the power of negative 6 divided by 0.4. Don't forget the squared minus 9 times, 9 times 10 to the power of 9. Is it 9? Yes. Multiply by 8.6 times 10 to the power of negative 8 divided by 0.1 squared. Don't forget the squared. Let me just confirm here. Cool. Then the electric, what is happening? No, 0.1 here. Okay. Very, very good number. Why am I getting a positive number? This is very, 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 very strange. Let me see something. At X. Positive, this one because it to go down. Positive minus. Okay. Something is fishy here. I don't know why. Okay, I think I repeated the same distance again and again. Oh, okay, okay. Another important part of no, this is open formers. Oh, I'm repeating the yo. Okay, let me repeat that. 9 times 10 to the power of 9 multiplied by 2.32 times 10 to the power of negative 6, then divided by 0.4 squared minus 9 times 10 to the power of 9 multiplied by 8.6 times 10 to the power of negative 8 divided by 0.1 squared. Okay, squared. Man, what is happening here? Oh, let me just put my on. I think my calculator in a way. So the inlet that I get there, it is positive 5300 Newton per Coulomb. That is the answer that I get. That is the answer that I get, 5300. Okay. So yeah, I guess. And you need to calculate the net. So we're gonna say upward. Okay, upward. Even though it's strange how it receives upwards, because wow, able. Let me repeat like for the last time. 2.32 times 10 to the power of negative 6 divided by 0.4 square that minus 9 times 10 to the power of negative, not negative, 9, 8.6 times 10 to the power of negative 8 divided by 0.1 squared. Okay, I get 5300. Okay, let me quickly see if the memo is saying that also. But yeah, I think it's the correct answer. I think it's the correct answer. Yeah, it is. It is the correct answer. So the net electric field experience at X, it is 53,000. Let me quickly confirm that. Okay, I'll come back now.